Hello, and welcome back to the pricing channel for small businesses. Today we're going to talk about another commonly used pricing strategy called full cost pricing. In many ways, it's similar to the markup pricing strategy we discussed in our previous video. But instead of applying a markup to a simple product price, as in a typical retail store, we will add the markup to a full cost for the product or service that is a sum of several different cost inputs. Full cost pricing is used in service businesses like auto repair shops, plumbers, and other trades businesses. It's also used in fabrication shops and in many manufacturing enterprises. It's particularly useful in situations where we know what the output of our business is, but we don't know how much of that output any specific customer will need. So let's take a look at how full cost pricing works. Full cost pricing is a pricing method that adds a profit margin to a unit cost basis for a particular product or service that we're selling. The unit cost basis is typically made up of both direct costs, like direct labor, raw materials, supplies, etc., from the cost of goods sold portion of our profit and loss statement, and also from the overhead cost portion of our profit and loss statement. Full cost pricing is used in service industries, like automotive service shops, used in fabrication industries, as well as some manufacturing businesses. The key objective of full cost pricing is to relate a known quantity of output from our business to a typically unknown customer need. And so, for example, if we want to charge X dollars per hour for a plumber, the total bill to a customer will depend on how many plumber hours are needed to complete the customer's job. And so typically in our business, we know how much output we're capable of delivering, like how many plumber hours per month, but we don't know how much a particular consumer is going to consume of our service or our product, and so we set up a price per unit for the service or product, and then what the customer actually uses determines what we charge them. This graph offers a different kind of illustration for full cost pricing. As you can see, we're plotting price on the y-axis and the quantity of something that we can deliver, either a product or service, on the x-axis. And so let's take the example of the plumber again. Let's assume that the plumber can work 40 hours a week, and 4 weeks in a month gives 160 hours a month. And so we can set our cost basis on that 160 hours a month as the quantity we can deliver of plumber time. So now at that point, Q, which is 160 hours, the overhead contribution to our full cost price is given by the vertical dotted line going from A to B. That's how much overhead we allocate to the plumber's function. The distance between point B and point C on the graph is the cost of goods sold unit cost contribution to the full cost price. And so at point C, we've now added up all the costs that are attached to the plumber who's working 160 hours a month. Then on top of that, from point C to point D, we add the profit margin to get the price for the plumber. Now, you may find this discussion somewhat similar to what we talked about with markup pricing in our last video, but here The cost basis is more complicated than just a simple product cost that we considered in that video. In that video, we talked about maybe buying a product from a wholesaler and then adding a markup to that, and that's what we sold it for, the price. Here, the cost basis is more complicated because we're adding several components to the cost basis. Just as a way of review, this is the profit and loss statement that we've seen in a couple of videos for a mythical fabrication company. And here we can see the cost of goods sold portion of that profit and loss statement. This is where the direct cost would come from. For example, direct labor, supplies, raw materials, parts. Those might get included in the unit cost basis for what a fabricator does. Likewise, from the overhead expense part of the profit and loss statement, we would pull some of these costs into the unit cost basis if we determined that those costs really did support the fabricator and his work for customers. So the cost of goods sold contributes to the unit cost basis, and the overhead cost also contributes to the cost basis. So let's assume, as an example, that we want to use full cost pricing to price out the fabrication work that our company does. And so we're going to use the previous slide's profit and loss statement as the basis for generating our hourly price for fabrication work. So first we'll start off with the assumption that of the $18,000 or so that was in the statement for direct labor, we're going to say $16,000 of that directly applies to fabrication. So we're going to include that cost in our calculation. Also, we're going to include $20,000 worth of raw materials, which always goes into what we fabricate for our customers. Supplies, miscellaneous things that we use of $300, all of those go to our fabrication work, so we'll include those in the unit cost basis. And then finally, of the total overhead cost we had on the profit and loss statement, we're going to allocate $11,000 of that to our unit cost basis for fabrication, because we've just made a decision that that's probably how much of our overhead really does support the fabricators. And so in a given month, the full cost for our fabrication services runs $47,300. Now let's assume that we have 2 lead fabricators, and so together they represent 320 potential hours of forecasted fabrication labor per month. Each of them works 40 hours a week, 4 weeks in a month. That's how we get to 320 hours. So the full cost per unit of fabrication is $47,300 divided by the 320 hours gives us $147.81 an hour. That's the full cost per hour for our fabricators to do work for customers. Now, let's assume for this example that we want to add a markup of $68.19 to the full cost to generate a price of $216 per hour. So that $216 an hour is what we're going to charge a customer to do work for them. And that price includes the labor, it includes the raw materials that we use to make stuff for our customers, and the miscellaneous supplies. Now, that markup of $68.19 might look a little contrived, and it is, but the reason for that number will become evident in just a moment. Now, when a customer comes in and he wants us to quote a job, or he wants us to do a job, the price we charge for fabrication services is $216 an hour, which includes raw materials and supplies used in the job. And so if he wants us to quote a job, all we have to do is figure out how many hours we have to apply to the job in order to get it done. And then we can deliver the quote to him. On the other hand, if he just says, come out to my place and do this for me, we add up however many hours are required, and then we multiply that by $2.16 an hour, and that's the price we end up charging him. Now, the reason why we chose a markup of $68.19 is if we apply that to the 320 hours of fabricator time we have in a month, it gives the total revenue of $69,121, which was in that profit and loss statement. So we're just trying to be consistent there. Now, probably a more typical way to go about this exercise would be to take raw materials and supplies out of the cost basis and only price this for labor, because probably we don't know what materials each customer is going to want us to use or need for us to use. So taking the materials out gives us the opportunity to just price our fabrication labor by itself. And so in that case, the full cost would be $16,000 for direct labor, and then the $11,000 for overhead we talked about earlier, which gives us a total of $27,000 a month of labor and allocated overhead to put into the unit cost basis for fabrication. So now in this case, the full cost per unit is $86.38 per hour. That's the $27,000 divided by the 320 hours of forecasted labor per month. So the full cost unit for labor is $86.38. Now, if we just decide to add a markup of 50% to that cost basis, then that generates a price of $129.57 per hour as the labor rate that we will quote or charge to a customer just for labor. Now, you can choose whatever markup you want to use. I just picked 50% here because it's easy to calculate. But the idea is, once we have the full cost unit basis, the charge per hour or the cost per hour, then we can add the markup, and that gives us the price. Now, one other thing to note about this is the unit cost basis is determined by adding up all the cost inputs and then dividing by the forecasted quantity that we have to offer. In our case, we added up the overhead costs, the labor costs, and then we divided those by 320 hours because we forecast that's how many hours of fabrication labor we can bill in a month, because that's how many hours our fabricators work. Now, so that's where Q is, at 320 hours. Now, consider a month where maybe we didn't have 320 hours of customer work available. Maybe we only billed 320 hours. That would put us at the vertical blue line there. Fewer hours than the forecasted number of hours. And what we see is, because we have fewer hours that we've billed, now the unit cost for our labor is higher. In other words, now instead of it being $27,000 divided by 360, now it's $27,000 divided by 320. And so the unit costs are higher, and our profit margin is smaller per unit that we bill. And so at the end of the month, we'll see that we have both lower revenues because we're only billing for 320 hours, and we'll see that our profit, our net income, or our gross profit, or our net income at the end of the day will be less because of the lower hours that we billed. So, to kind of summarize the process here, the first thing we have to do is to identify what are the cost inputs for either the service or the product that we're trying to price. So we need to gather all of those. And probably the most difficult part of that is looking at our overhead and trying to decide how much of our overhead applies to what it is we're trying to price. We then relate this to an output of the business, and that helps us decide which cost inputs go into the calculation. We then have to decide what the forecastable quantity of output is, or how much output's available, or how much output we expect to be able to offer. So in the case of our fabricators, we were offering 320 hours per month. Dividing the total costs that we identify in our example, dividing that by the total output available, in this case 320 hours for the fabricators, gives us the unit cost figure for our output, be it service or product. Then we apply a markup to that unit cost figure. We used the example of 50% here. You could use whatever you think is appropriate. And this generates the unit price that we can use if someone asks us to quote on a job, or if they ask us to do a job and then just charge them for whatever it is we apply to that effort. As mentioned in the presentation, we can use full cost pricing to create quotes or bids for customers. Let's say we estimate a certain job will require 15 hours of our labor. If we have a full cost price per hour for labor, it's relatively easy to calculate or generate a quote for a customer. Likewise, if an auto body shop spends 4 hours of labor fixing a problem with our car, the labor portion of the bill will be 4 times their full cost price for their labor. Here is an example of an auto repair bill I received for a little work that was done on my car. They used exactly 1 hour of labor to fix the problem my car had, and their full cost price for their labor is $90 an hour, and that's what appears on the bill. Now, I hope this presentation on full cost pricing has been helpful. If you have any comments or questions, please leave them in the comments section below. And for sure, don't forget to hit that subscribe button down there so that you don't miss a single video. And as always, I look forward to seeing you again.